Alright, so the last part of this midterm, part 4, we have just the question number 8. So here for number 8, we want to turn this recursive solution of the power function into an iterative function. Here's a note. We cannot use the power symbol or the power function. So basically this is meant to sort of like strip you from shortcuts. We really want you to think about how to turn this into an iterative solution, and I think the best first step is to think about what is sort of going on in this recursive function. Like, how does it work? And if you understand that pretty well, then you'll have a good idea of how to turn it into an iterative function. Okay, so let's just go through it, shall we? I want to start out with an example. If we have power of 2 to 3, we will expect this to be 8, right? Because 2 to the third should be 8. But one thing you might want to notice is that you can also write this as 2 to 3 equals 2 times 2 times 2, which is 8. Alright, so I like to write things out like this or find some kind of pattern like this because it shows me what is the sort of repeated step that I want to do in my recursion. What is the sub-problem of this original bigger problem? Okay, so here you can kind of see it in the recursive call. So we have x, which in our example would be 2, and then we would have 2 times of power of 2, and then I guess this would be 2, 2. Alright, so actually let me walk through this example. Gotta clear this first. Okay, so let's just draw the recursive call stack for this, which if you don't know is just basically the stack of all the calls to power and how the computer evaluates them. So this can be really useful to visualize how the code is run. Alright, so our first call will be power of 2, 3. Right, so we look at the base case. It says if n equals 0, return 1. Well, we don't meet it because n is 3. So this leads to become, this should lead us to the return statement of 2 and then times power of 2 and 2. Right, so we can't actually, evaluate this immediately because we don't know what power of 2 is. If it was a specific value, we could just immediately return that value. But we have to keep evaluating until we have a specific number. Okay, so power of 2 goes to this part of the statement because it doesn't satisfy the base case. Then it becomes 2 times power of 2, 1. And then we call power of 2, 1. And we get the same thing again because n is not equal to 0. Power of 2, 0. Alright, so now n is equal to 0, and this just returns 1. Alright, so this is our call stack. We evaluate it going down, and then we have to resolve the frames that we didn't close. So all of these lines, when we call them, we actually never closed them because we couldn't. We didn't know what specific value they were. So now we sort of multiply up. So it becomes 1 times 2 times 2 times 2. So this whole call, this one right here, becomes 8. So that's sort of how you would visualize how this recursive solution works. Okay, so it hinges upon the fact that 2 times 2 times 2 equals that. Alright, so how can we turn this to an iterative solution? Well, you might think of right away that you should use a for loop. And for n times, we want to multiply our result by x. Right, so in this example, we want to multiply well, let's say our result starts at 1 or something like that, then we want to multiply it by 2 3 times. Okay, so let's just code that up. Say result equals 1. So this is my storing variable. And I'm going to say I equals 0. And also I'm going to say, well, I is less than n. Result equals result times x. Okay, and then we also have to increment our index, or else we'll be trapped in our while loop forever. And bad things will happen. Okay, and then we just return result. Alright. And I'm also gonna, just for the sake of things, I'll write the for loop for this. So everything is the same up to this point. If you wanted to do a for loop, you'd probably do, actually, you don't need this line for the for loop. So you would just say for I in range of n, result equals result times x, and then return result. So I kind of like the for loop better because it's much shorter. Well, it's shorter by 2 lines, so not that big of a difference, but it is a lot cleaner, I think. Okay, so just to be absolutely clear, let's walk through the example again, but using our iterative solution. Okay, so first result is actually I'm gonna make a table here. So this is also another way of understanding how your code is working. This is a good visualization tool, I think. Okay, so I'm just gonna keep track of everything. So we really just need to keep track of what our result is and what our I is. So at first our result is 1 and our I is 0. And after the first iteration of the while loop, result becomes 2, I becomes 1, result becomes 4, I becomes 2, result becomes 8, and then I becomes 3. And since I is not less than n anymore, then we have to exit our while loop and return result. So we get 8. Alright, so that's it for problem 8.